Hi, I'm Ofri, CEO and co-founder at Edgify. As my co-founder Nadav mentioned during his chat, we have built a platform that utilizes federated learning algorithms to solve real-world problems, specifically in the domain of computer vision. In this next session, we will deep dive a bit into a use case where we took our computer vision federated learning solution to the test. Though our distributed collaborative training framework is agnostic in nature, we wanted to dive into each use case as to make the right adjustments and to make sure that the distributed collaborative training part of it is relevant for that specific use case. The one we chose to discuss with you today is fresh produce recognition at checkout, specifically in the grocery retail industry. Self-checkout systems are a great way to cut the queue, usually. That is, if all the items you're buying in your cart have barcodes on them. But what happens when you're trying to buy something that is fresh or barcodeless, like fruit, vegetables, something from the bakery? It would be great if you could scan these fresh produce just like you scan a can of Red Bull. It seems so obvious to have some kind of solution that allows you to just scan these fresh produces, or at least rely on computer vision to do so. Yet it's strange that we haven't seen massive deployment of this computer vision solution across big name grocery retailers.
So there are actually three main issues with training a computer vision model for recognizing fresh produce in a self-checkout environment. The first issue is that you cannot train a model in a lab setting and count on that model working well in the supermarket environment. Things are very different between what you can take here and what will be what the fresh produce will look like in the supermarket. Different lighting conditions, different angles, and actually different items from different providers will make your model work a lot worse in the real environment than it will work in the lab. Now, the second issue is even if we train a model in the supermarket and it will work well in that supermarket, it doesn't ensure that it will work well in another supermarket. Again, same reasons. Lighting is different, angles are different, and maybe the machine itself might be a little bit different. So you cannot just make do with training the model in one supermarket and counting on it working in another. You actually have to collect data from all the supermarkets you want to operate in. Now, those two issues are solvable by just collecting a lot of data from a few supermarkets, all the supermarkets you need, uploading the data to the cloud, training your model with a bunch of GPUs, and just deploying it back. But that brings me to the third issue with this whole thing, is the variability of data. Data in the retail industry is very non-constant. It changes over time, new produce gets put in, all different items vanish due to seasonality, and even the same type of produce changes over time because of, again, seasonality and different providers and everything else. So you cannot just keep your model constant once you train it. You have to keep retraining it and updating it over time.
For these three reasons, a sustainable model needs to be retrained on the weekly basis on the data that has been collected on actual edge devices that are going to be used for inference. It is easy to understand why training on the cloud is just not a visible solution. Even if we accept the higher server cost, the network bandwidth of the supermarket is not large enough to handle that kind of data transfer without crashing. Federated learning works perfectly in this scenario. Shopper buy a new item and feed our system with ground truth on every available edge device. We then use the computing power of the exact same devices to train a model. We can do this daily if we want, so the model is always up to date.
One final challenge that comes from a collaborative distributed framework is the control. Because when you're training on the cloud or you're training on a server, then you have a lot of control, and there are great platforms that allow you to monitor and check and maintain the training of your model. And so to kind of put this all together per use case, we had to create some form of management of the different edge devices. And I'll take you through the quick platform we have created, but just to show that these kind of solutions require a very detailed edge device management solution. Well, when you're going to train on the edge, first and most important thing is the edge device. It's important to be able to add and remove these edge devices quite fluidly as more and more add on to your network. So adding a new device or removing a new device need to be at your fingertips, much like uploading 4 GPU and removing GPU. Obviously, each device should have its own token, and that way you can manage it independently. Once we have the devices, you want to be able to start a training job just the same rate as you could if you had this data centralized. When starting a new job, it's really important that you have the ability to both select what kind of data set you want to use for that job. Is it data set that's being gathered and generated live on the edge devices, or as mostly done, start with a certain static data set that you've pre-uploaded. Once the job is started, and here you can see a job that we started a couple of days ago and ended a couple of days ago on 4 real devices. You can track the entire operation on a network level, not per device, so that you can see all your devices kind of coming together to create this one model, and then save it as a model so you can use that model to deploy potentially on other edge devices. And once you have that model, you can even dig a bit deeper, because as you don't get to see the data itself, it's important that you understand how much data was used for each one of your classes. So here, though you can't see the actual data or the actual images, but you can see how many samples were taken from the entirety of your edge device network. So you can see that you've collected enough data to create a relevant model. And then once you're happy with that model or automated, you can always need the ability to deploy it, because training on an edge network means that some edges train more fiercely depending on footfall, and some edge devices might not see as much data and have as well of a trained model. And so the ability to deploy models between edge devices is crucial.